Hello, and thank you for watching our presentation. I'm Samantha Stahlke, and together with my colleagues Atiya and Pejman Mirza-Babaei from the UXR lab at Ontario Tech University, we will be presenting our work on an automated playtesting tool. So, we all know that playtesting is a critical part of games user research to answer questions about player understanding, challenge, enjoyment, and pretty much every other aspect of user experience. Playtesting is essential. But there's a problem. Playtesting is expensive. You've got overhead for your testing team and lab space, and of course you have to pay those pesky participants. Then you've got to analyze all of the data from those participants, and the next time you want to test, you really want to find new participants that will be seeing the game with fresh eyes. Plus, more playtesting usually happens later in development when substantial changes may be difficult and expensive to make. In other words, testing with humans is inconvenient. So our work is motivated by this question. Can we take some of the burden off of playtesting with humans? Can we use AI for playtesting?
Using AI to play games is certainly not a new concept. Board games like chess and Go and more complex digital games like Dota have been an AI testbed for years. AI has also been used to test and improve games. King, EA, and Ubisoft have all explored in-house solutions for automatic evaluation of things like level difficulty and combat systems. Most of the tools created in this space are proprietary or heavily game-specific, though Unity has also released a toolkit for general reinforcement learning that can be used to develop in-game character AI or testing tools. We looked at all of this and we wanted to make a tool of our own for automated playtesting. We wanted our tool to be generalizable for different games, accessible to designers without a technical background, and freely available for anyone that wanted to use it. And so we created PathOS.
PathOS allows designers to simulate player navigation in 3D game environments with AI agents. We want our tool to help designers answer questions like whether players will get lost and quickly compare player pathing between alternate versions of level geometry. PathOS isn't meant to replace human testing, but rather provide some approximate data without the time and expense of a full playtest. For instance, PathOS might help in between playtest iterations while refining level design. We made PathOS as a free extension for Unity. If you're interested in checking it out, you can download PathOS on GitHub. Our agents implement a simple expert system based on models of how players see, remember, and make decisions with game information. Our model of player sight uses simple culling tests based on level geometry and apparent size to determine what an agent should see. Our memory model means that agents can forget or mix up information about where objects are in a level to help mimic the mistakes a human player might make. Lastly, agents have customizable personality profiles that determine their preferences in what to interact with. For instance, an agent meant to imitate a cautious player will be more likely to avoid objects that are flagged as hostile.
PathOS agents navigate a level by taking the information available in their memory and creating a list of possible destinations. These destinations are score-based on the agent's simulated personality before a high-scoring destination is picked to use in pathfinding. This process is repeated as the agent moves in the world, creating a rough prediction of player movement. To support developer workflows, we created a user interface so that designers could see what was happening inside an agent's head in real time. We also created utilities for simulating many agents at once and reviewing results via path visualizations and heat maps.
We conducted a user study for PathOS with 9 game developers who we asked to use the tool while designing 2 levels for a simple RPG-type game. Our participants were very positive about the utility of the framework, finding its predictions useful in refining their designs. Several participants commented on the potential time and monetary savings of the tool over traditional playtesting. We also identified several areas for improvement in the tool's user interface and proposed additions to its functionality. In our future work, we're hoping to evaluate the accuracy of PathOS's predictions. We're also hoping to test it with a commercial developer, implement the improvements we identified, and look into working with machine learning. Thanks again for watching our presentation. You can read more about our implementation and user study in the full paper. We look forward to answering your questions.